Aloha, everyone. Welcome to the PISCES Space Science Symposium. This is a virtual talk series exploring some of the very cool stuff happening in the world of space exploration with the people who are making them happen. My name is Chris. I'm the Communications and Outreach Officer for PISCES. We're an aerospace research and education program at the University of Hawaii at Hilo, and we're kind of focused on advancing space technology and giving education and hands-on career training opportunities to students along the way. Tonight, we're honored to have Dr. Yajaira Sierra-Sastre joining us. She's a nanomaterials scientist and educator with more than 15 years of research and development experience. She's currently serving as a senior program manager at Blue Origins, where she leads the crew mockups development for the MK2 lunar lander program. And before working at Blue Origin, she worked at NASA as an engineering project manager for the Mars sample return and Viper rover missions. And you also have a connection to Hawaii. In 2013, you were selected to be an analog astronaut at the high seas habitat on Mauna Loa. I understand that you were with 5 crew members over 4 months, staying in a very isolated little habitat and trying out kind of what it'd be like to live on another planet. Mauna Loa is very much like another planet if you're not in view of anything else on the island. Yajaira has been a highly qualified applicant for NASA's astronaut candidate program, and she aspires to fly to space someday. Tonight, she's going to share some of her journey from her nanoscience research to now working in the aerospace sector and the robotics and human spaceflight mission she has worked on, as well as how she has applied her interdisciplinary approaches during her career transitions. And if you have any questions during the presentation, feel free to pop them into the Q&A chat window, and we'll get to them at the end of the talk. Thank you, Yajaira. You can begin when you're ready.
Thank you. Thank you so much. Thank you, everyone, for joining us today for my talk, for this talk. Let me share my screen, and we will get started. Okay. Excellent. So, as Chris mentioned, I am Dr. Yajaira Sierra-Sastre. I am a scientist. I am an educator. I am an explorer. Currently working and living my dream of working in space projects and in the aerospace sector. And my hopes for today is that I will share my story and I will give you perhaps ideas or inspire you to pave your own path in STEM, in a career path, a career path in space. Pave your own path and leverage, the diverse ways and approaches that you may apply to define your own path in research, STEM, or space. So a little bit about myself. I am originally from Puerto Rico. This is a beautiful picture of my hometown of Arroyo, Puerto Rico. I was born and raised in the island of Puerto Rico in the Caribbean. And I always say that Puerto Rico, my island, was the lab that I had growing up, and the place that inspired me, instilled in me this curiosity to explore the universe, both under the blue sky and above it. I was one of many people in STEM and space that have been inspired and were inspired by pictures like this one. Astronauts on the surface of the moon. So since I was very little, I have always loved the topics, related to space exploration, all those topics. And I have not grown old, and that has been a passion of mine since I was little. And now, as I mentioned, now I am lucky enough to see those space dream, coming true as I work in the sector. But my career path and my career in aerospace, or to basically like what is now a career in aerospace, was not a linear path. Was not a traditional path either. I started my career, and I will talk a little bit about, the science behind the work that I did when I was focused on scientific research as a nanoscientist. But over the course of my career, I have reinvented myself multiple times. I trained as a nanoscientist. I also have a background in science education, and I have taught at many different levels, from high school to university and grad school level. And I have been a simulated astronaut. I have worked for industries that are not related to space. And I would say that this diversity of experiences, it has been amazing. My career, my life in STEM has been amazing, filled with wonderful adventures, excitement. And I believe it's these diverse experiences what has equipped me and enabled me now to apply interdisciplinary approaches and multidisciplinary approaches to innovation. Innovation in the nano world, as I will talk with you about, and innovation in outer space, as the work that I am doing right now. So how did I get started? It started with STEM and a academic career in space. So my background is in chemistry. So I have a bachelor's degree in chemistry from the University of Puerto Rico. I earned a teaching certification. Actually, my first job in STEM was as a high school chemistry teacher. And but in my mind, I've always had this, kind of like curiosity and desire to explore a career path in research and becoming a scientist. I mean, going back to school, grad school, and formally get trained to do science. So that curiosity and desire to pursue research path was what took me from the Caribbean to upstate New York to work to study at Cornell University and earn my graduate school degrees in nanomaterials science. I fell in love with nanomaterial science, with that world that is too small to see. I just fell in love with it. I was super curious about space, but my first exposure to research was in this field of nanoscience, and I loved it. So as part of my PhD work, I focus on exploring the use of biomacromolecules. Like that's a big word, but biomacromolecules are natural nanoscale structures at the nanoscale that we can find in nature. So, for example, DNA strands are a natural nanoscale material, and that can be used as a scaffold, as a template to arrange other types of nanomaterials, such as nanoparticles, right, on the surface of these biomacromolecules or biotemplates. So I have on the bottom left here some pictures of examples of biomacromolecules. So you see the DNA. Well, you can see it, but what they are seeing is a transmission electron microscopy image with tiny dots, and those tiny dots are metallic nanoparticles that are bound to these DNA strands. You see in the middle schematic representation of a virus, and viruses as well are nanoscale, nanoscale structures, scaffolds that could be used to grow this type of like metallic nanoparticles in situ. And to the right in green and yellow, that's a scanning electron microscopy image with a sketch of what these two-dimensional protein arrangements that are found in many bacteria in nature, how those nanoparticle arrangements can be used as a biotemplate as well to arrange nanoparticles in very specific configurations and very specific configurations at that scale. And back then, and it has been a long time, but back then when I was in grad school, this was a very hot area of research because at the nanoscale, size matters. At the nanoscale, organization of the nanomaterials matter. And back then we were exploring not just metallic nanoparticles using this type of two-dimensional protein arrangements, but we were also using the nanoparticles as catalysts to grow semiconductor nanowires. And those semiconductor nanowires, examples or images of those are shown in the upper right. What you see is top view and tilt views of scanning electron micrographs of nanowires that were grown from these nanoparticles that were arranged using this type of biotemplates. So as you can hear right from me, like biomolecules, nanoparticles, nanowires, semiconductors. So certainly this was a very, very fun research topic and thesis to work on at the intersection of all these areas. I had to learn how to extract protein from bacteria, which is something that microbiologists do, to using this type of microscopy techniques to explore and evaluate and study these type of like inorganic nanostructures, such as semiconducting nanowires, and how we were controlling their growth. And we did that. We even like, I even look at early studies on how to use these semiconductor nanowires since they were so like present in such a high density. So we were looking at how to use them for lithium-ion battery applications and so on. So very, very, very fun like research and very fun experiences at the intersection of all these fields. I say now as an aerospace professional that once upon a time, I was an architect of small things. Now I am focused on managing and supporting teams that are building and designing big things for space. But back then I was an architect of small things. I was designing materials, studying these materials. And at the end of my graduate school, what I had to offer to the world was this technical toolbox that was highly specialized, but at the same time very diverse, very interdisciplinary or multidisciplinary. That took me to my first job after grad school, after earning my PhD. So what I did was I decided to join a startup company that a colleague and a lab mate had created, a startup. And I started as a research scientist in this startup company. I was able to work and support and lead and manage several projects for focus mainly on nanomaterials and nanocoatings for different types of applications, from environment, batteries, medical devices, and smart textile applications. And these were smart materials, materials that were inspired by nature, such as, self-cleaning coatings or coatings that we could apply to fabrics, as I am showing here to the left. Coatings and nanomaterials that were inspired by nature, by natural structures again. So there are some leaves in nature, like the lotus leaf, that when you see it in the ponds, you can see how that leaf can repel water. And that's due to tiny, tiny structures on the surface of that of the lotus leaf. So as a nanoscientist, I looked for inspiration in nature to try to recreate and imitate and create inorganic materials that could resemble these natural structures, to render and create new properties, such as self-cleaning, add self-cleaning attributes to garments when we would apply these type of materials on the surface of garments. So by being inspired, in this type of natural structures, we work, and I work in projects where we design materials like tiny nano needles that will be super hydrophobic, so will repel water while also blocking UV rays. So very, very, very fun stuff, very, very fun stuff, interesting stuff. and interesting materials, from wires to nanofibers that would encapsulate drugs and would help, and could serve as wound in wound dressing applications for healing wounds, and microsphere sensors as well, with materials that could detect different types of analytes in certain environments. So as the beginning of my career after my PhD, I would say getting exposed to the startup, this experience of working for a startup, working for a very small team, getting exposed to so many different types of projects, and learning how to draft, like contribute to drafting proposals for federally funded research, drafting patent applications. So I learned a lot. So after serving a few years in these startups like iFiber, and then another startup focused more on materials for lithium-ion battery applications, 2012 came, the year of 2012, and that was a very special year for me because NASA had announced openings for the NASA astronaut candidate program. And even though I was really happy with, nanoscience, the passion I had for space was still there. The interest, the curiosity I had for the industry was still there. My dreams of going to space were still there. So I decided, to give it a try. I had the few years of experience that NASA would expect astronaut applicants for the astronaut candidate program to have. So I had the qualifications, for education. I have the years of experience, and I said, hey, let's give it a try. I was not selected. I am not a NASA astronaut yet. Was not selected back then, but I was part of the highly qualified applicants for this program. And as part of my quest to perhaps improve my chances in the future of being considered for such a program, I started looking for opportunities in research to then started looking for projects that were related to space. And that's how I learned about the HI-SEAS program. That year as well, I decided to be more proactive, and while doing some contract work for one of the startups, I decided, you know what, let me attend a space conference. So I attended my first space conference where I met Neil Armstrong. So wow, like I set a very high bar for that space conference. And that space conference was the Next Generation Supervital Researchers Conference. Little did I know back then that, nowadays I would be working for a company that has, created these rockets to send humans to the suborbital space, in suborbital trips to the edge of space. So this was a pivotal or a year that I look back and say, yes, I practiced proactiveness. I was bold to go, and pursue these dreams, and started, creating, opportunities to transition my career from nanoscience to the space sector. And with HI-SEAS, I applied to it. I was selected. I was part of this crew. And as part of the selection process, since this was the first NASA-funded Mars analog mission that was part of the HI-SEAS program, applicants were asked to provide research proposals. So I submitted a research proposal. You guess what? I submitted a research proposal to evaluate nanomaterials that could be applied to fabrics. That's what I was doing back during my startup years. So I decided to submit a proposal to evaluate these different types of nano coatings with antimicrobial properties that could render astronaut garments, could provide astronaut garments properties, cleaning properties or other resistant properties, so that astronauts in the future during long duration spaceflight missions, they could use these garments over extended periods of time. So I did that. I guess the programs really liked it. And this was very interesting as well, a very interesting research experience for me, because yes, I was combining, or as part of the proposal, I was evaluating this type of nanomaterials, my expertise, but then the research was happening with human test subjects in an operational environment. And research in operational environments can be messy, The data can be messy. And this was like a project at the intersection, talking about interdisciplinarity, right? At the intersection of material science, human factors, and with this application, right, for space exploration. So we were looking at not just the fabrics or garments, the performance of these garments over extended use and repeated use by the test subject. We were also interested in learning people's how people felt about wearing the same piece of garment over extended periods of time. So we look at different types of ways of gathering this information through questionnaires to capture, and gather data about the sensory attributes of these fabrics, how the users were rating, the odor of these fabrics, or the feel, how the piece of garment felt. Did it feel heavy or dirty or itchy or damp, over time. So we look at all that. I would say this project and this research was my introduction to this area of human factors and human system integration. And all that happened in this habitat, in the high seas habitat that you may know, my colleagues in Hawaii. So this is a habitat located on Mauna Loa volcano in Hawaii. It's still there. Back in the days, 10 years ago, the habitat was used by researchers at the University of Hawaii and Cornell, researchers funded by NASA to explore human performance, team dynamics, as well as different types of food systems over a period of over a series of Mars extended extended Mars analog missions. Mine was a 4-month-long mission. These are members of my crew, and it was a 4-month-long mission in this habitat, living in close quarters and isolation and confinement, with just a few windows to look at the outside, eating freeze-dried food, exercising like astronauts do in space. And due to the relative distance between Mars and Earth, a communication delayed, a delay in communication was also simulated. So communications were restricted, meaning no Skype or real-time conversations with family and friends for 4 months. We got to do simulated EVAs as well to explore the surrounding areas in Mauna Loa, and we partook in a series of research projects in collaboration with CSA, the Canadian Space Agency, looking at their Juno rover and doing some simulations and operations with the Juno rover, and some other types of research looking at our ability to detect food related odors over time, and so on. So I would say one of the highlights of my career, it felt like a dream come true. I didn't have to escape Earth to feel like an astronaut, living and working on this pseudo Mars. And that's me with my Puerto Rican flag next to the habitat. What a wonderful experience, exciting, adventurous, really, really fascinating experience. After those 4 months coming back to Earth, that was not hard. That transition between Pudo Mars and Earth was not hard. I was able to go back to my, routines and old habits, et cetera, et cetera. What was hard was feeling that I was once again at a crossroads, with regards to my career. Thinking that, well, after this Mars experience, what am I supposed to do? And back then, I mean, the most obvious thing to do was, okay, let's look for jobs in the space sector, and let's continue pursuing a career in space. I can apply to many, many, many different jobs, and nothing materialized back then. Many different jobs in the space sector, and nothing materialized back then. In some ways, I felt that I was like an outsider to the industry because of my non-traditional path. So it did not work. It did not work. Like I had this awesome experience at Pudo Mars, and it did not work. Aerospace did not work back then. So I started looking for other job opportunities out there that would align with my skill set and the skill set that I had to offer. And this is super crazy. So from Mars, I ended up finding a position with the U.S. federal government at the U.S. Bureau of Engraving and Printing. This is our U.S. money factory, where money is paper money is printed every single day. I like saying that once upon a time I had a job where I make millions of dollars every single day, literally. I did not keep it or bring it home, but I made millions of dollars every single day. And I found this opportunity to join the Bureau in a research scientist role to support projects that will develop the next generation security features and anti-counterfeiting strategies. And I found it fascinating. It was like, okay, this is not space, but this sounds really interesting. And what you see here is a picture of a $100 bill highlighting some of the security features that are present in our, in our banknotes nowadays. So we were looking at the future. We were looking at, how we can improve these technologies that help cashiers and bank tellers and the general public determine if that piece of paper is real or not, if that banknote that they have in their hands is real or not. Nothing related to space, but this was the job that exposed me to these other, season or phase in my career as a not just as a research scientist, but as a technical project manager. So during those 5 years that I worked at the Bureau of Engraving and Printing, I learned how to become a project manager. And project management, that role is what eventually took me to NASA and opened doors to work at NASA. Again, not related to space, not necessarily what I was passionate about. It was not something that I planned for to work in the banknote industry sector, but certainly like a season in my career where I grew a lot and gained new skills, project management skills, knowledge about the government side of federally funded research, knowledge about, like what's to be like to work in a manufacturing, environment, because we were there like working day by day, day to day in the factory. So a different set of experiences that I can say, sure, it kind of felt like a derail in my path to aerospace, but no experiences in life and your career will go to waste. That's what I believed. And I have embraced that. I have embraced and put it to good use that, this diversity of experiences, one way or the other one will benefit the future jobs you or the future organizations you will serve, because you bring this, a diversity of skill sets that are very, 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 very useful. And I can tell you a little bit about, those type of like project management skills that if you are a scientist and perhaps, you are trying to, or student, young professional trying to figure out, okay, do I, continue a path, a scientific research path, academic path, working in academia as a professor or a researcher, or should I, explore other career paths? Project management is one that, again, I never planned for it, but it's a career path that I have also like discovered that it can be very exciting as well. And this is why, as a technical project manager, you will still need to have and show competencies in the technical area you're serving. So your STEM background, your STEM degree will be useful to define, to understand the technical scope of work, to communicate that technical scope of work to different audiences. But you also, as part of the nature of the job, you also apply and develop other types of skill sets. So leading cross-functional teams, that's something that I find very, very, very exciting in my career. So I need to interface as a project manager. I interface with scientists, with engineers, but also with procurement specialists, or with a CEO, or with the director of your organization. And having that type of like experience of interfacing with different people of different types of backgrounds, for me, has been very, very, very exciting. Communication, again, as a trained teacher and an educator, that's another part of project management that I enjoy a lot. Being able to translate technical knowledge to different audiences. So when talking to scientists and engineers, you can then communicate in a more technical way. But if you are talking communicating technical work to other audiences, you need to be a good translator and find a way of communicating effectively so that other audiences and not technical or specialized audiences understand the scope of work you're focusing on. You need to be a good administrator, and you need to learn how to balance resources. Project management is about balancing the technical scope, the quality of the work, with other resources such as the budget you have available, the cost, and the schedule, when projects need to be delivered and when tasks need to be completed. And as a project manager, you're a leader. You're accountable for delivering results. So you need to be very good with people. That's a very good, useful skill, but mission-oriented. So good managing people, relating to people, forging relationships with people, while keeping your focus on the mission. Projects have a beginning and an end, and you are accountable for the success of completing those projects. Having strategic thinking, that's another useful skill that you can develop as a project manager. Being exposed to the big picture, not just the tiny gritty details about the science or the technology you are working on, but how that technology connects with the business at large and the company's objectives. You need to be a visionary, and you need to be a forecaster. You need to be able to look at the state of things, status of things in the project, and be able to forecast, what the outcomes will be if you choose path A versus B, for example. Dot connector, that's another descriptor that I like for good project managers, being able to connect people, be able to make connections between technologies and disparate disciplines in the field. You need to have a lot of endurance, and you need to learn how to pick your battles and put out the right fires every single day. So a lot of endurance, because depending on the industry, projects are created, others are closed or stopped. Scope can change. Sometimes you need to enhance or your scope. Sometimes you need to de-scope activities. So you need to keep yourself flexible to keep the passion for the project you are working on, while like being adaptable if changes are needed. If changes are needed to better serve the organization. So that's what I did for 5 years at the Bureau, did project management. And meanwhile, I continue nurturing my passion for education, public outreach, and continue looking for space jobs, continue creating my own opportunities in the sector. And this is one example of a project that I loved working on. So I led a team of students in Puerto Rico that built this tiny CubeSat or cute CubeSat at the right, bottom right. And this was actually a CubeSat that was designed to collect air samples in the stratosphere. And it's a CubeSat that was selected to fly in the Airbus Perlan glider. It's a glider that can reach the stratosphere in the area of Calafate, Argentina. And I had the honor of working with these awesome students from Puerto Rico in this space-related project. Not all CubeSats go to heaven, as one of our mentors used to say. But this one went very high up there to look for signs of fungal spores in those regions of the stratosphere. So I believe that combination of project management experience with the federal government and my proactiveness, with continuing, like to pursue opportunities and creating opportunities in aerospace is what led me to this opportunity at NASA, or the opportunity to work at NASA. So in the meantime, from working with students to continuing doing field work, taking courses in planetary geology, to keep that connection with, analog research. All those experiences then led me finally to this opportunity at NASA. And back in 2018, I decided to attend a second conference, and this is where I learned about, the need of the agency for someone with experience with Mars and a seasoned project manager that would could join the agency to be a project manager in support of the Mars sample return program. So I finally saw one of my dreams come true, a dream of working for NASA. And this is me at NASA Glenn Research Center, where I supported 2 teams. One of the teams was working on the Lunar Viper rover. This is the Artemis rover that NASA will send to the lunar South Pole. And this rover will look for water ice or ice. And we'll look at the lateral and vertical distribution of water at the lunar South Pole. And this is very important because now NASA and companies, we have our sites in that region of the moon in support of the Artemis missions. We want to go back to the moon, and this time to stay. And we want to learn, about, the resources that are available and that could help support the sustained presence of humans on the lunar surface. So that's me. In the background is ED Engineering Development Unit of that Viper rover. Viper stands for Volatiles Investigating Polar Exploration Rover. So anything that is volatile, anything like water ice, those are some of the things that Viper will be looking at when NASA, the agency, sends the rover very soon, end of next year, I believe. So that's me with some of the engineers, female engineers, and that were part of this program, of this project. And this is a picture of the Simulated Lunar Operations Laboratory. It's a super cool lab at NASA Glenn Research Center. You see this beam with simulated lunar regolith, and some of the mobility test engineers in the background, positioning the rover. This is a lab that it has a slope, to actually look at and evaluate the performance of these rovers at different types of, gradients and slope angles, and using this simulated lunar regolith. And so this team did a lot of testing, mobility testing in support of the program, to better understand how the rover performed when traversing that terrain, simulated terrain, and traversing obstacles such as rocks, and so on. So from the moon to Mars, I supported the Lunar Viper rover project, and I also had the opportunity to support the Mars sample return mission. And these are pictures that you may recognize from Perseverance, rover Perseverance, and awesome pictures that were taken during the landing of this rover that NASA sent to Mars, that landed in February of 2021. And is the rover that is on the surface of Mars right now, collecting samples, the samples that the Mars sample return mission will attempt to return or bring back to Earth. This rover is a Jezero crater, an area that scientists believed was flooded with water, and where there is water, or there was water, there was as well, and there is the potential for life. So these are samples that we want to bring back to Earth to look for any biosignatures, any signatures that of presence in the past, right, of past microbial life, that would, answer one of the most fundamental questions of humanity. Are we alone? I mean, as living beings, is life only present on planet Earth, or in planet Earth, or can we find presence of life, life forms and microbial life in other areas of our solar system, other parts of our solar system? This is a picture of Perseverance. And I was not part of Perseverance. I am giving you the background of Perseverance, because Perseverance basically is the rover that is collecting these samples that then the Mars sample return mission will bring to Earth. And this is a schematic representation of some of the elements that and systems that are part of MSR, Mars sample return. So right now, and again, I left NASA, and I work now with Blue Origin, but one of the most recent architectures was exploring the use of helicopters to help Perseverance bring these tubes back to the rocket. As part of MSR, humanity will see the first rocket launch from the surface of Mars. And there will be a spacecraft orbiting Mars, and the samples will be transferred from the rocket to this sample return orbiter, or spacecraft responsible for bringing the samples back to Earth. So right now the configuration is looking at helicopters. But back then, when I was at NASA, we were also exploring concepts for future rovers, in support rovers that could support this mission. And that one of the concepts that was explored back then, when I was working at NASA again, was the sample fetch rover, which was a rover that was going to help Perseverance again to bring these samples back to the rocket. And you can see this rover here, the sample, like a concept of the sample fetch rover, and you can see the tires, the wheel and tire assemblies, and that we were working at that time. So I was the project manager for the Mars Spring Tire program and team. This is a team at NASA Glenn that designs flexible tires for rovers, lunar and Mars rovers. And these tires are inspired by the Apollo lunar roving vehicle back in the day. And but it's based on new technology developed and invented at NASA Glenn, and in collaboration with the company Goodyear. So these are tires, rover tires that have shown demonstrated to have improvements in terms of traction. They are made of a mesh of steel springs and the shape memory alloy springs, I should say, and a novel material that has enabled innovation in this area of rover tires, because it has improved. It's a material that helps, with helps with designing tires with improved traction, at the same time that it adds durability properties to these tires. So if you are familiar with the Curiosity rover, this picture in the lower left corner shows one of the rigid wheels of the Curiosity rover and all the extensive damage, because the Mars terrain is hard to traverse. So teams like the Mars Spring Tire at NASA Glenn Research Center worked on materials innovation in the area of shape memory alloys. And shape memory alloys are materials that that exhibit reversible phase transformation at the nanoscale, at the atomic scale. So these are materials that can compress and stretch, and that will not deform permanently. So very fun work, and again, work at the intersection of where I was able to work at the intersection of material science and support the teams and have a working knowledge on the types of materials they were working on because of my background, but also a project where, as a project manager, I was applying my project management skills as well. So very fun stuff. And NASA, as part of the NASA mission, right? NASA is focused on research and technology for the benefit of all. NASA Glenn, these technology of shape memory alloys. The last time I look at the news, the technology is being considered for applications here on Earth. And finally, so now at Blue Origin, I transitioned from 8 years of experience in the federal government, and now I am working in the private sector at Blue Origin, as Chris mentioned, as a senior program manager, specifically as the lunar crew mockups lead. So building those mockups that we will use to inform design, to understand the configuration of our vehicle, and mockups that are used for human-in-the-loop evaluations. So I am part of the lunar transportation project of Blue. And if you don't know about Blue, our vision at Blue as a company is to enable a future where millions of people are living and working in space for the benefit of Earth. And the way we are going to accomplish that vision or make that vision come true is to radically reduce the cost of access to space by building reusable rockets, by building technologies that will enable a future where we will be able to utilize in-space resources, and by inspiring the next generation. Because in order to enable that vision of millions of people of living and working in space, this is a multi-generational effort, right? And as part of our mission, and I love this part of Blue, we are here as well to inspire the next generation. And for those of you who are curious about what else Blue is doing, so besides the lunar transportation and the landers that we will build to transfer or to transport astronauts to the lunar surface as part of the Artemis program, NASA's Artemis program, as I mentioned earlier, Blue has the New Shepard program, a program that flights humans to above the Kármán line as part of the suborbital flights in the New Shepard, using the New Shepard rocket. The New Glenn is our orbital rocket that will enable our access to low Earth orbit and beyond. Blue Origin also works in the engines sector, designing and building their own engines, and in space systems as well. So once again, and finally, living my dream in the aerospace sector, now working from working on Mars back to the moon as part of the Blue Moon project, supporting the crew lander for Artemis. We are all across the country. We have facilities all over the country. And yeah, if you're interested, I want to invite you to look for opportunities. If you're about to graduate, look for opportunities as well to join our team. And that's all for today. Thank you for being with us, and I hope you're inspired to pave your own way and your own career path to space.
Mahalo, Yajaira. Thank you so much for sharing your story and your experience with us today. It's really inspiring to hear about all the ways that you applied your skills and knowledge kind of in different applications. So we're going to have some time for questions now. I'm going to stop the recording.